Thank you all very much for coming. There's some seats up here if you're... I just wanted to see what the perspective was from your height. Very nice up here. Does that ruin your picture? Hi, Mom. Okay. I'm down. Sorry, I wasn't supposed to do that. Okay. Oh, great. No, I don't want to update. My name is Joe Palca. I am a reporter with NPR, formerly known as National Public Radio. Typically, when I give a talk, I try to do it without notes in a relaxed manner, speaking off the cuff, as it were. It's a style I've found works very well for me. But I have heard that using PowerPoint can help me communicate my ideas. Help me make my points more effectively. Help me engage my audience. So I decided to give it a try. What do you think so far? Am I making myself clear? Okay, that's the end of that. That usually goes well with people who've seen one or too many PowerPoint presentations. So this talk I'm about to give, which will be over soon, is a sort of a mashup of two things that I've become a little bit obsessed about. One is this notion that you need to talk a lot to explain things or to give enough information to make something understandable. And people say, oh, how can I explain nuclear physics in 2 minutes? And the answer is, you can't. I mean, I get that. You really can't. But that's not what the media's role is. I think you can explain a lot of things to a level of abstraction that's enough for the general public to understand in 2 minutes, and you don't have to apologize for it, although clearly I'm still apologizing for it, so maybe you do have to apologize for it. But anyway, so part of this talk is to give you some examples of things that I did in 2 minutes that I think pretty clearly explain to you what you need to know about a particular topic. Not that you could teach it, not that you could pass an exam in it, but simply that you are informed about it and understand its relative importance in the world. So that's part one of the talk. And part two of the talk is my views, which are my own and completely idiosyncratic, and I'm prepared to disavow them if anybody accuses me of having them. But my views about the nature of science in the media, because I do think that news and science are sometimes awkward. And as I was saying at lunch today, and I'll say this now so you can laugh now and not later, scientists like to say that most science is incremental. So usually things go in small measure. And they also like to say that the literature, the scientific literature, is self-correcting, which is to say if a piece of work comes out that turns out to be wrong, not for any fraudulent or misconduct reason, just simply a misunderstanding of the data or misreading or using the wrong equipment, the literature corrects itself. But another way of stating that is that most scientific research is either trivial or wrong. And that's the less charitable way of putting it. But my argument is that having accepted that and being clear about that, then we don't have to go around pretending that every scientific advance is some sort of news breakthrough. Now, I get it. I work in a news organization, and as I was explaining, if you run into the newsroom and say, hey, there was a small earthquake and very few people were hurt, you don't get much attention. So you have to say something that's a little more exciting. But I've decided, maybe because I'm at the end of my career and they feel sorry for me, that I can do things that don't pretend to be more than they are. So I tend to focus on things like why ants don't have traffic jams. And you know, you can probably live your life without knowing that, but that's where I'm at the moment. So this actually is timely because we just had one of these. This is something you don't see very often, which is usually when you get to 2359, you get 59 and you don't get 60. But in June 2012, this happened, and it happened a few years earlier. And this is the story I did about a leap second in 2005. And I'm just going to play this for you because, as I said, it lasts about 2 minutes, and we can talk about whether I captured the information or not. Oops, that didn't help, did it? So if I'm here, and there's a little button there, and I click on that button.
We're going to take a break from today's big story to bring you this item, which is about time. You'll have more time to celebrate New Year's Eve this year, but not much. The international body that's charged with keeping time on track has decreed that there will be a leap second added to the end of 2005. NPR's Joe Palca explains why.
The reason is there's time, and then there's time. Once upon a time, a second was defined as 1/86,400 of the time it took the Earth to make one revolution on its axis with respect to the Sun. Astronomers liked that definition because it meant the Sun was directly overhead at the same time every day, high noon. But some timekeepers don't care about things like stars and the rotation of the Earth. For them, time is, and always should be, a constant. The Earth's rotation is wobbling all over the place. Why, the rotation is affected by things like melting glaciers, El Niño, even the tides, they cried. So the constant time crowd likes what the 13th General Conference on Weights and Measures came up with for a reference in 1967. Namely, that a second is the duration of 9,192,631,770 periods of the radiation corresponding to the transition between the two hyperfine levels of the ground state of the cesium-133 atom. Now, there's a number you can hang your hat on. But this left everyone with a problem. The time based on hyperfine levels of cesium and the time based on Earth's rotation have a habit of slipping out of sync. Earth is rotating just the tiniest bit slower than it used to. So every few years, the International Earth Rotation and Reference System Service, aka la Service International de la Rotation de la Terre et des Systèmes de Référence, decrees that there will be a leap second to make up the difference. The last one was at the end of 1998, and the next one is at the end of this year. Enjoy. Joe Palca, NPR News, Washington.
Now, does anybody have any idea what I just said? Well, my argument is, well, I only play that piece of tape so I can play this piece of tape, which I'm particularly fond of, and you'll know why in a second.
Joe Palca's story about the leap second that's coming at the end of the year brought this comment.
I'm writing to congratulate you on a very clear presentation of the principles of atomic time and the need for leap seconds. This is a difficult topic, and your report handled it very well.
That's from Judah Levine. He's with the Time and Frequency Division of the National Institute of Standards and Technology in Boulder, Colorado.
Now, see? So at least somebody thought, I mean, that actually, every once in a while I think, okay, I got it right for Judah Levine, because he already understands it. So the question is, did I get it right for people who have no idea what I'm talking about? And this is actually an interesting conundrum for me in the media. People say, what do the public think of this, or what do the public think of that? And the answer is, most of the time, I have no idea. Because nobody tells me, except for the people who write to NPR and post a comment on the website. And I was sitting next to somebody at a meeting or a dinner party the other night, and she was wearing a wristband that absolutely captures my feelings about comments to stories that I do on the internet, which is the wristband said, never read the comments. Because for some reason, people feel it's okay to be vituperative and nasty when they comment on something, and they can't be bothered when they have something nice to say. Well, maybe some of them do, but it's amazing how unpleasant the comments are, and truthfully, they may be right, but you could say it in a nicer way. So I don't know if you guys are old enough to remember flaming, but this is like torching or something. These guys just go nuts on comments. But anyway, my point is, I don't know whether that was understandable or not, but I think it was. And I think in 2 minutes, I gave you some sense, at least enough sense, about why we're talking about leap seconds. And what you'll find, and this is what my friend George Johnson of the New York Times says, we create the illusion of knowledge. Because you listen to the piece and you think, oh, I get it. And then you go home and try to explain it to your roommate or your mother or something, and you think, oh, maybe I really didn't get it. And I'm okay with that because, as I said, I'm not trying to educate you. If I were, I would sit here after the piece and I would go through it with each of you and we'd make sure that you understood it because there'd be a test at the end of the semester and you'd have to learn it, right? But I don't have that. My audience comes in, they listen, they go away, they do something else. So I don't have the same expectation for them, and I don't think I can. I mean, imagine a course that met at times that I can't tell you in advance for 2 minutes a day. You know, that's not how you develop a syllabus for a course in education. So I'm not saying I'm not educational and that people will learn something from listening to me, but I'm just saying I'm not education. So let's go on to another brilliant example. Oh, this one. This is kind of funny. So this gives this. I put this one up because it gives you a sense of the timelessness of science news, even though science news is this just in. So this is a story, as you can see, about the understanding the pathways and the processes that our brain use to control our perception of itch. Because what is itch? Itch is sort of an operational. Itch is when you want to scratch something. I think that's a great way of describing it. But so there are obviously something happens on your skin, or you imagine it's happening on your skin, or whatever. And there's a set of genes and proteins and pathways that are activated when this happens. So I was at UC Berkeley about 18 months ago. And I interviewed this woman, Diana Bautista. And then about a year later, I was feeling really guilty because I hadn't put the piece on the air. And Bautista called to me and said, we've just had a paper accepted in a prestigious journal and wondered if you wanted to write a story about it. And I said, great, but I think I've already got the tape that I need. And the fact is that the news, the paper in the journal that was coming out that week, I didn't even need to talk to her about because that wasn't the interesting part of the story. I mean, it was, but it was the timely part, but it wasn't the interesting part. So what I wound up doing was I was actually in California again, so I wasn't in my office. I had all the tape on that laptop computer you saw. I wrote the piece in the field with the tape I had recorded a year ago. And the new bit, which obviously I didn't have her saying, I said. And so I was able to use year-old tape in a Today news story. And then the other funny thing that happened, I found this funny, maybe you won't, but I was in San Francisco and I needed to record my voice. And I carry around usually a microphone and a tape recorder so I can do that pretty much wherever I go. But the idea is I want to do it in a quiet room. And a room like this is great. You hear there's not a lot of echo. There's people clicking cameras, but that's okay. It's a very sound neutral room. You get very used to listening for background noise, like there are air handlers in here that editors would complain about. But if you can find a really room with these padded walls and a lot of absorbing material, like your clothing and stuff, that's a great place to record. And I was staying with a friend of mine who was flying in from the East Coast, and she was late, and I was there, and I said, well, she's a radio reporter. I said, where do you usually record your stuff? And she said, I usually go into my closet. I said, okay. And so there I am, squatting down in the closet with her dresses and shoes and everything, recording this piece, thinking this is the strangest place I've ever done a story from. I mean, it's okay, but it was a little odd. But then see if you can hear the dresses rattling in the background when I play it. So here's this piece on, let's see, where do I get the, oh, there it is, up there.
Scientists have just scratched the surface of another important problem, why some things make us itch. Today there's progress to report. Researchers in California have found a molecule that may be crucial for our brains to sense itch. NPR's Joe Palca has more.
How do you go about discovering what makes us itch? Well, if you're Diana Bautista at the University of California, Berkeley, you ask what molecules are involved.
We say, okay, what are the possible molecular players out there that might be contributing to itch or touch?
Bautista says it turns out itch and touch, and even pain, all seem to be related, at least in the way our brains make sense of these sensations. But how to tell which molecules are key players? Bautista says basically you try everything you can.
We test a lot of candidates, and if we're really lucky, one of our candidates, we can prove that it plays a really important role.
And now she thinks she's found one. Working with colleagues at the Buck Institute for Research on Aging, she's found a molecule that's made by a gene called HTR7. When there's less of this molecule, animals with itchy skin conditions like eczema do less scratching. When there's more of it, itching gets worse. The way this molecule works is kind of interesting. It changes how sensitive brain cells are to a chemical called serotonin. Now, serotonin is a chemical that's related to depression. So Bautista's research might explain why certain antidepressant drugs that boost serotonin have a peculiar side effect. For some people, the drugs make them itch. Bautista says the new research is certainly not the end of the story when it comes to understanding itch.
As soon as you discover something new, it just poses more and more questions.
In other words, it'll be a while before researchers scratch itch off their list of topics to study. Bautista's work appears in the journal Neurona. Joe Palca, NPR News.
So did you catch that long description in the middle where I talk a lot? That's where the news was, and everything else was from her from a year earlier, because it's the process that doesn't change. I could interview people today, and when they find something new, I could just drop in all the process parts of the interview and say what the news bit is. And people have been asking me, how do you know what to cover? And the answer is, frequently the news per se is the least interesting, because what was that gene called again? I can't even remember. I said it 2 seconds ago. The point is, it's not which gene it is or why, it's the process of learning how to find out. I'll play one other piece, and then we part 2 of this fascinating talk. This one I really liked, because people have been saying to me, how do you cover things when you really don't understand it? I mean, how do you know how to explain these complicated topics? And so this is an example of how that works. It's also an example of one of the worst introductions ever crafted by an editor at NPR. Oh, see, I did it again. All right, here we go.
From NPR News, this is All Things Considered. I'm Leanne Hansen.
And I'm John Idstein. This week, Americans are likely to purchase more than 1 billion eggs. At least that's what we did last year. According to the American Egg Board, that's 50% more than the average for a week.
Wow, that's interesting.
This isn't just any week.
Oh, really?
Eggs feature prominently in the holidays of Passover.
Oh, yeah,
Christmas,
Passover
right?
and Easter, that's
Easter,
right.
which is Sunday.
So what have eggs
also on scientists' minds.
Oh, it's a piece about science.
Why a hard-boiled egg spun rapidly on a tabletop will flip upright and start spinning like a top. NPR's Joe Palca has the story.
As a practical matter, it's easy enough to show that if you set a hard-boiled egg on a table and give it a good spin, it will start off spinning horizontally.
It's fun. Have you ever done this?
And then start spinning upright. The hard part is explaining why it happens.
I thought this would be an easy problem, but it turned out to be really very subtle and quite tricky. It took us a long time.
Keith Moffat is director of the Isaac Newton Institute for Mathematical Sciences in Cambridge, England. He's drawn to problems involving spinning objects. 2 years ago, he published an article in Nature about the physics of a coin spinning on a table. Now, as he said, the explanation for why an egg behaves the way it does is tricky. Moffat did his best to explain, without equations, what happens once the egg starts spinning.
Its axis of symmetry will get a little bit inclined to the horizontal, and that means that this point of contact moves horizontally relative to the center of mass. Now, when that happens...
If this is sounding complicated to you, and perhaps a little hard to grasp, I know how you feel.
The rate of, what we call rate of precession of the axis of symmetry around the vertical. Are you still with me on this?
Yeah.
Okay.
Actually, that was not exactly the truth. I was holding on for dear life, and it only got worse.
Now, this is the tricky bit, because there's a bit of math involved that I think is just unavoidable. But it follows from this property that the height of the center of mass.
But as Moffat taught, it should become a bit clearer. After the egg starts spinning horizontally, two forces, known as friction and slippage, combine to get the egg wobbling. As it starts wobbling, some of the horizontal spin gets transferred to vertical spin. And as that happens, the same forces that make a gyroscope spin on its end start making the egg spin on its end.
The gyroscopic forces must exceed the natural effect of gravity, which is pulling the center of gravity down.
All right, okay, now I'm getting there. So in other words, as it begins to wobble on the table, it starts to appear more like a gyroscope, and at some point the gyroscopic forces take over and it does flip up on its axis.
Yes, that's absolutely right.
That was close. Moffat says he's not done with spinning objects. He's thinking about working out the mathematics that explains why a raw egg spins poorly on a table. Another problem, he says, is obvious until you try to explain it. And maybe after that, an explanation of how an irregular object like a pebble spins on a table. For now, I'll stick with hard-boiled eggs. Joe Palca, NPR News, Washington.
So you can only get away with that once or twice in a career. Shush, shush.
There's more detail on
Oh,
our website,
yeah.
NPR.org.
I got to cut that out. Anyway, so you ask how you do things, you don't understand what the heck you're talking about. You keep asking questions. Where is this, my friend who was asking me what journalists need to do? You keep asking questions until you think you understand what's going on. And a good way to find out if you know what's going on is to do what I did there, which is, so what you're saying is. And if the answer to so what you're saying is yes, that's good. And if the answer is no, that's a stupid thing to understand, that's bad. Okay. All right, so much for that part of the talk. Now, the other part of the talk, as I said to you, is the nature of news. I'm going to kind of whiz through this so that we can have a chance to talk with each other. But so as I sit in my office the other day putting this together, and I was thinking, okay, what are the big news stories of 2016? Well, it's only February, but I mean, nobody's going to have a hard time coming up with a list, right? I mean, there have been the primaries, there's ISIS, there's Iran, there's the European immigration problem. That's kind of fallen off the table, but that's still out there. Black Lives Matter, well, we haven't killed anybody recently, so I suppose that's not important anymore. Fetal tissue, well, people are trying to keep that in the news. My point is that there are a ton. However, in the last month, who can come up with, and I'll give you more than a month if you want, a single newsworthy science topic? And I'll give you a hint, there's one. Who said CRISPR? Very good. Yes, you win. Planets? What's new with planets? Oh, yeah, that's right. That is a big one. Yes.
Man just supposedly cured HIV for an entire island. Charlie Sheen included.
I actually missed that. Planets are good. I mean, you guys are, oh, yeah, go ahead. Sorry. Yes, thank you. That was the one I was thinking of. But planets, yes, the 9th planet. Although, okay, I mean, we had a big debate about whether to cover that. Not a big debate. We had a debate. They haven't seen it. It's a theoretical model that says it should be there. So when does that become news? When they find it or when they say it ought to be there? Interesting. Zika virus, no question about it. Science and public policy, although how many people here are worried about catching Zika? Good. You're right. So the question is, why is the media doing round-the-clock coverage of Zika? Good question. That's for the master class. I can't go into that now. No, I think it's because it's a panicky situation, and there have, I mean, the WHO helped the cause by saying it's a health emergency, and the CDC recommended against travel. I mean, yeah, you say that. I think people have a hard time understanding the relative risk that Zika, certainly Ebola, my goodness, the overreaction to that was stunning. Did any of you get Ebola during the last outbreak? No, huh? Okay. Wouldn't have known that from the media because you thought, or certainly from the politicians, because they were figuring that most of you would have had it by now. Okay, so my argument is there's a lot fewer. Those are the two I came up with. CRISPR, does everybody know what CRISPR is? Raise your hand. Good. Well, then I can keep doing stories about it. CRISPR is it actually should be CRISPR-Cas9, don't hate me. It's a new tool that allows you to edit the genomes of living cells. And it's going to have a huge impact on science and possibly, and I'm hedging my bets on this because I don't like predicting therapeutic outcomes, but it could have a huge impact on human disease. I'm uncertain about the latter. I am absolutely certain about the former. It's already had a huge impact. So that's the problem, you see. What do you do when you're a science correspondent and you want to be on the news and there's not a lot of news to be on? And I've solved the problem, as I say, by trying to pick stories that I think people will be interested in without trying to say, and you have to know this because it's going to affect your life tomorrow, because that's what journalism is supposed to be about, something that's important today to you. And so in a way, I've painted myself into the last segment in the show corner, which is, this is so unimportant, we would have bumped it, but we didn't have anything better to put in. But that's okay, because for the most part, I'm happy about that, because frankly, when my stories get bumped, and this one did get bumped, so that they could put in a stump speech from one of the candidates in Iowa, I'm going, if that's what you think is news now, fine, go for it. Because I don't think so. I've heard the stump speeches. I know what they're talking about. I don't need to hear that again, but fine. Never mind. This is a great country. What's big science news? That's my other point. Who knows? And I've got three examples here. So, does anybody remember, this is the Nobel Prize in Physics from 2010. Graphene, do you remember that? That's this single monolayer of carbon atoms. And the way they discovered it was well, it wasn't just this, but they put a piece of Scotch tape on a piece of carbon and they pulled it off. And they wound up with this single layer of carbon. Fantastically exciting. So when the Nobel Prize comes out in 2010, or any year, the Nobel Prize Committee puts out a press release to say, here's what the prize is, here's what it's for, and it usually gives the paper that the first publication in the scientific literature about this finding. So this was the paper that they put in the press release. It was a paper in 2004 Science magazine. Now, every week on Monday morning, I get that week's Science magazine in my inbox. I know every article that's going to come out that week. It's embargoed. Do you know the term embargo? It means I'm allowed to know it. I'm not allowed to tell anybody until the embargo is lifted. The embargo is lifted the night before publication. Why the night before and not the morning of? Because the network news people wanted to put it on the air and they didn't want to follow the newspapers all the time. That's the truth. I'm the network news, so that's I can say that. So you would think that the issue of Science magazine that came to my desk on Monday morning in 2004 with this article that was so important that it won somebody a Nobel Prize 6 years later would have gotten my attention, because as you heard, I am a prize-winning science correspondent. He didn't tell you about all the other prizes I've won, but they're equally impressive. And so I went to look to see how I had covered this important paper in 2004, and I and anybody else in the world, and that's all I could find. Notice this list is notable for the absence of NPR, New York Times, Washington Post, Wall Street Journal, Economist, Newsweek, Time. Pick your favorite heavy-hitting news organization, not there. New Scientist, do you guys know this? Funky British publication. They probably picked it up for the same reason the Manchester Evening News picked it up. That's Manchester, England. Because the two guys, Novoselov and Keim, were working at the University of Manchester in England, and the University of Manchester put out a press release. I'm not on their press list, so I didn't see it. These other guys, I haven't quite figured out where they got it from, but never mind. Anyway, my point is, we don't know. The CRISPR paper came out in 2012. Did anybody cover it? No. It's being covered like crazy now, and guess what? When it wins the Nobel Prize, it'll be covered like crazy again. And the point is, we don't know. We, journalists, smart and clever as we are, don't know what's important. And so we miss a lot of stuff. And just as another, everybody got it when it won the Nobel Prize, right? This is another example I'll just blow through. This is, anybody know about RNA interference? These are short stretches of RNA that can turn genes off temporarily. I'll only say that much. These guys won in, again, the paper came out 1998. It won the Nobel Prize in 2006, so it's 8 years. And I went back to see who covered that. There was none. 0. But we all got it when it won the Nobel Prize. One final one. I only do this one for reasons which will become obvious in 1 second. This is the induced pluripotent stem cells. Have you heard about this? This is the idea that you can get these stem cells, which are marvelous cells that can self-renew until you say turn into a brain cell and they turn into a brain cell, or turn into a skin cell and they turn into a skin cell. It used to be people thought you could only get those from embryos, and there was a big controversy in this country about using human embryos for research, or even discarded embryos for in vitro fertilization. So this was 2012. The paper came out in 2006, and I haven't looked to see who else did it, but I know one major news organization that covered the 2006 announcement. Yay! Because I was at the meeting where he talked about it, and I knew everybody was like fantastically excited, and that was Yamanaka. I didn't know John Gurdon, but I knew Yamanaka. Anyway, that was really great. High point for me. The other thing that happens is the media jump all over things that can't possibly be true. This was a paper that caused a lot of attention. A bacterium that can grow by using arsenic instead of phosphorus got a ton of news coverage, as did the article a year later, absence of detectable arsenate in DNA from arsenate-grown cells. So completely wrong, but generated a lot of attention. Why? Because it was amazing. If it were true, trouble was it wasn't. And just to say it's not just them that do this, it's me too. Who will live to be 100? Genetic tests might tell. That was a paper in Science. Poor peer review cited in retracted DNA study. So I did that one a year later too. Okay, why science becomes news. This is my favorite slide. It's getting old, I'm afraid, but I will now apologize to anybody who would give me an F for this slide for not labeling the axes very well. But I will now tell you that this axis is the number of citations in the Nexus search and database for news stories, and this axis, the x-axis, is dates starting in January 2011 and ending in May 2013. And the question is, what was the search term that I put in to Nexus that generated this month-by-month return of how many times that particular term was used in the media? Well, if it were 2013 in April, you might have gotten it. Does anybody want to make a guess? It's impossible. No. You couldn't do it, but anyway, I'll show you. BRCA. Okay, does everybody know what BRCA is? It's the BRCA gene. It's the gene that, when mutated, can lead to an increased risk of breast cancer. And the question is, what's going on? Exactly. Was there a breakthrough in science? No. What happened? What sent BRCA into the news? Angelina Jolie announced that she had breast cancer and that she said everybody should get tested for the BRCA1, BRCA2 gene. That's why science becomes news, not because of science, right?